Hey everyone, so we're here with the What is a Calorie Lab, which is our way of measuring the amount of chemical energy stored in food, or a calorie. So for today's lab, the entire purpose behind it is to see how much energy is stored in the chemical bonds that we find in different foods. Now when you as a human being eat the food, you break it down to its constitutive monomers, so that way your body can further break it down through cellular respiration to provide you the energy to move. It's very difficult for me to measure that energy once it's inside of you. However, we also know that that chemical energy stored in the food, while it can end up as energy for you through cellular respiration, can also be released as heat through the process of burning. So today's lab is going to explore the calorie content of 3 different popcorns or chip-like substances to see how they stack up, which are the highest and which are the lowest calorie, based on how much heat they release. The way we're capturing the heat they release is by seeing how much they're actually heating up water. So to explain our experimental setup, I'll ask Becca to do so.
Okay, so everything that goes into this lab is not too complicated, but I'll break it down for you. So we have here, it's a cork with a paper clip that is just going to act as a stand. So it's going to hold whatever we're burning up a little closer to our water so that we know that we're heating just the water and not as much of the air around it. So this is a boat, is what we're gonna call it. It's just a little piece of tin foil that I wrapped up, and it will sit right on top of there and hold whatever we're burning for us. This is also going to assist us when we weigh it, as before we burn them, we're going to weigh both the boat with whatever we're burning inside of it, both before and after, to see how much we burn off. So next, the water that we're heating up. So there is 150 milliliters inside of this beaker, 150 milliliters of distilled water, or tap water, excuse me, inside of our beaker. And you can see that we have the thermometer that is in the water, completely submerged, which comes up, and we can see that it is roughly 21 degrees right now, which is right above room temperature.
This is very important because you want to be able to actually read the thermometer, not have it blocked out by the cap, but it needs to be submerged in the water, so that way you know that it's actually measuring the temperature change of the water in the beaker.
This is also measured in degrees Celsius, excuse me. I didn't say that, I believe. So now there's a little lid that'll go right on top of our beaker. And just a twist secures it in place. And this will sit right on top of our little cylindrical piece here, which is going to help us hold all of the heat in, as when we do the experiment, we will move it on top of what we're burning, and it'll help keep the heat inside of here to warm just the water and not as much of the air around it.
So now, Becca, why do you move the water to the boat and not the boat to the water?
We want to move the water to the boat because otherwise we're moving around the piece that we have on fire. And if you were to drop that, we don't want you to burn yourself, as well as you're going to be wasting more time trying to move that underneath here rather than just lifting this entire apparatus up and setting it on top.
So you would not advise moving fireballs around?
I would not advise moving the fireballs around.
All right, that sounds fairly solid advice. We also have a scale that you're going to be using to measure the weight of the popcorn before and after. And here we have our 3 popcorn samples. So take a moment to think about which of these you think would have the highest calorie content and which of these would have the lowest. So rank them. And we'll join you in a minute to discuss our hypothesis. All right, so here we are to discuss our hypotheses about where we think these different popcorns rank in terms of calorie content. So our first popcorn is that of sea salt. No other flavorings. I don't think that one's going to have a lot of calories because salt does not have calories. Our next is a honey butter kettle corn. Now, unfortunately, Becca gave me a full report about the flavor profile of this one. Not as good as it sounds.
Not great.
Not great, but I do love me some honey and some butter. And last up, we've got our cheesy poofs. Corn puffs with cheese. With cheddar, in fact. Given those three possible types of popcorn, Becca, which of them do you think is going to have the highest calorie content and which of them is going to have the lowest?
My hypothesis is that the honey butter kettle corn is going to have the most because it is covered in butter and caramel, which is just sugar, all that good stuff.
Okay, and now which of these is probably going to have the least?
I am saying that the, sea salt popcorn is going to have the least because, like you said, salt does not have any calories in it.
All right, I'm going to agree with you there. I think that we are in agreement that the sea salt popcorn is likely to have the lowest calorie content, but I do not think that the honey butter kettle corn will have the most because I think that sugar coating is taking the place of the lipid coating and the fact that these cheese puffs are fried, and lipids, or fried foods, have a higher calorie content for the same weight as sugars and proteins, because if you read the whole lab, lipids have 9 calories per gram, whereas sugars and proteins have 4 calories per gram. But we could settle this. We could find this out. How are we going to find this out, Becca?
We're going to burn them, Paul.
We'll see you when things are on fire in a second. All right, so now we're going to light things on fire. Explain our setup, Becca.
All right, so we have our scale over here, which is zeroed out right now just where we want it. We have all 3 of our kinds of popcorn that we're going to be burning. We have our boat, which is what we're going to be burning in. Again, our stand and our heating apparatus. And then our note paper.
So you're going to be recording a lot of this data here. And I think for our first one, since we agreed that the sea salt popcorn is our most likely to have the least calories, let's start by burning that one, huh?
Sounds good to me.
All right, so what's first?
The first step is we need to weigh our boat because we are going to need to get the difference of this weight and when we add in our popcorn and stuff. So 2.45 is boat weight. Now, I'm going to pick one of my pieces of popcorn here, and we'll weigh this. And my pre-weight is going to be 2.61 in grams.
And now the names of the popcorn might not match the printout page, but that's fine. Go ahead and just reassign the names, and you'll be doing multiple replicates of these different popcorns. So 2.61 grams is our starting weight, our pre-weight.
Yes. And now, before we do anything else, I want to get the temperature on here. And it looks like it is at 21 degrees Celsius.
Perfect.
We'll track that in pre-temp.
And keep in mind, if that goes well above room temperature, so anywhere near 30, anything above 28, you're going to want to change the water out. So that way you're not losing too much energy to just the water sitting. So keep in mind that you want to keep that water close to room temperature.
All right, now I'm just getting my popcorn set up so it'll make it a little easier for me to burn. Make sure it'll sit on my stand here.
This is a very precise science of MacGyvering this setup.
Oh, couldn't bother to buy me nice lab equipment. So
I got called out. I got called out.
All right, now that we have all of our pre-weight and our pre-temp tracked, don't need anything else here. Oh, I can write on my sheet, our water mass is 150 150 grams.
Now, how do you know that it's 150 grams, Becca?
I measured it out in a graduated cylinder before putting it inside of our beaker here, Paul.
But you measured it out in milliliters, but you just wrote grams on that paper.
Yes, I did. It's because milliliters and grams are transferable. 1 gram is 1 milliliter.
That's a thumbs up. All right, let's set this thing on fire. Lit. Under it goes. Watch to make sure that it's still burning in there.
That's it.
It certainly is. Heating up the water underneath. Still see fire going. A little bit of smoke comes off the top. It clearly didn't burn the whole popcorn, but that's okay. We'll give it a minute here to equilibrate. Water went up at least a degree so far. All right, 1 degree. Seems like the fire went out, so let's go ahead and take a look at what's left. So not all the popcorn burned, which is totally fine. We now need a post weight.
We also need a post temp. So since we still have that up on the thermometer, we said it went up 1 degree Celsius, which brings us to 22 degrees Celsius.
And our post weight.
Make sure our scale is 0. 2.55 grams. All right.
Cool. Now we can fill in our weight change and our temp change, and that way we can count our calories. But we want to do 3 replicates of this. So how about we do another replicate for the camera and see if we can get that whole popcorn to burn, Becca?
Sounds good to me.
So we'll just run it back.
Just leave that there.
We already know the weight of the boat, so we can just do the pre-weight on this bit of popcorn.
2.74. This one's a little bigger than last. 7.5.
A little bit bigger.
Let's see if this one will set up nicely.
All right. Try to get the base on fire here if we can. Looks like it's burning. Oh, still going. There we go. Much more of it's burning this time.
It's like the art of watching water boil.
That's literally it, right? This is an educational video. Something's still on fire there. The smoke's coming out the top. Let's check to see what's going on with our water temp. We started out at 22 degrees Celsius. Right now at 23.
Now, Paul, how much would we be required to stir in the water if we know that heat rises?
So you want to give it a chance to even out. You might give it a little bit of a shake to see if that goes up. Oops. Trying to get that to focus on the... Come back on the thermometer. There we go. How are we reading that, Becca? Does that look like 23.5 maybe?
23.5 to me, Paul.
All right. Not quite the entire popcorn burn, but again, we just need a pre and post.
Back over. 2.68 grams.
All right, so in class, you'll be doing this for our sea salt popcorn, honey butter popcorn, and our cheddar puffs. Those 3 popcorns, 3 replicates each, to see if we can get an average, so that way we can rank them. Let's fill in our data for the rest of these off camera, and then I'll see you back for doing some math. All right, so here we are with the empty data table that you'll find in your lab. We have our equation for number of calories per gram of our popcorn. The components of this equation are important. You will be expected to cancel the units with this equation. The variables here are mass of water, which we know to be equivalent to our milliliters, which we had 150. The specific heat of water, which we know is 1, but it is used as a conversion factor because it measures 1 calorie per gram degree Celsius. And then our 2 variables are our temperature change, where you're taking post-temperature minus pre-temperature, and weight change, pre-weight minus post-weight. I'm going to show you how to do the calculation for our first repetition and encourage you to do the calculations for the remainder as practice. So from our numbers from before, we started out with 2.61 grams on the boat, and then after the burning, and of course this was not white cheddar, but instead sea salt popcorn, our post weight was 2.55 grams, and so 2.61 minus 2.55 is 0.06 grams. Our pre-temperature was 21 degrees Celsius, our post-temperature was 22 degrees Celsius, and our temperature change was therefore 1 degree Celsius. Now we can calculate our calories here. So this equation is 150 times 1 for our CW times 1 degree Celsius for our temperature change divided by 0.06 grams. So plug that into your calculator. And you get 2,500. So hold on a minute. You're telling me that that little bit of popcorn had 2,500 calories? Not quite. That little bit of popcorn had 2.5 calories, as you see on the back of your food label, because that calorie has a capital C. The capital C indicates that it is 2.5 kcal, or kilocalories. So in order to make it equivalent to the calories that you see on the back label, you need to move the decimal place over 3 places. So that is our calories for our first metric, 2.5 cals, because I am using that capital C. You need to go through and with the numbers posted online or that you got from your lab, calculate the calories for each of our 3 different types of popcorn. In doing all of this, I also want to illustrate what happens with our units, because this is important. Our mass of water is reported in grams. Our CW, or the specific heat of water, is in calories per gram degree Celsius. And temperature change is in degrees Celsius, and weight change is in grams. You can cancel these terms. So I'll grab another color here and write it out. We've got grams times calories per gram times degrees Celsius times degrees Celsius divided by grams. Our cancellation would look like this. Degrees Celsius by degrees Celsius, grams by grams, leaving you with your final metric of calories per gram in the popcorn that you burn. So, please make sure you understand how to cancel units, and please make sure that you can calculate calories for your food given this data table. Additionally, come exam time, you know that a gram of lipids has 9 calories per gram. A gram of carbs or sugars has 4 calories per gram. And a gram of protein has 4 calories per gram. I could ask you how to calculate calories given these experimental variables, but I could also ask you to calculate calories from macromolecule content. So if I told you that the food you were going to be burning had 1 gram of lipid, 0 grams of carbs, and 1 gram of protein, how many calories are present in that food? Well, 1 times 9 is 9 calories from the lipids. 1 times 4 is 4 calories from proteins. Add those together, meaning that you're getting 13 calories in that food. So please be able to go either from macromolecule content or experimentally derived calorie counts.